Welcome back. 5 videos in, we've built a complete RAG system from scratch. Smart chunking, advanced retrieval, and an agent that reasons about what to search and when. In this series finale, we step back and ask the question that separates architects from implementers. When should you not build RAG at all? 5 search calls, an agent that reasons and retrieves, and still a mediocre answer. Not because the database is wrong, not because the chunks are bad, because this question is fundamentally about relationships. Who reports to whom? Which teams overlap? Vector search finds similar text, it doesn't follow connections. This isn't a retrieval quality problem, it's an architecture mismatch, and that changes the question entirely. Over 5 videos, we've built the complete RAG stack: smart chunking, advanced retrieval, and agent that reasons. It's a powerful system, but we've only ever asked how to build it better. The more important question, the one that separates architects from implementers, is when should we not build it at all? 3 scenarios, 3 different answers. Relationship dense queries: who reports to whom, which components depend on which. Vector search finds similar text, it can't follow a dependency graph. Static domain knowledge: if TechWall's legal style never changes, retrieving examples every query is waste. That knowledge belongs in the model weights. Keyword sensitive domains, error codes, legal citations, SKUs. ERR 4291 doesn't have a semantic meaning. Pure vector search drifts to similar errors when you need exact matches. The best RAG system is sometimes not a RAG system. For relationships, GraphRAG. For static knowledge, fine tuning. For exact terms, hybrid search. We'll cover each one in this video. Let's start with GraphRAG. We've already seen the standard RAG pipeline: chunk, embed, retrieve. GraphRAG, published by Microsoft Research in 2024, takes a completely different approach. Instead of chunks, an LLM reads your documents and extracts entities and their relationships. Not what a document says, who connects to whom. Those entities become nodes, relationships become edges, a traversable knowledge graph. GraphRAG then detects communities, clusters of tightly related entities, and pre builds a summary for each. When a query arrives, it traverses the graph and retrieves those summaries, not fragments. The question about team overlaps, the answer is already mapped before any query ever arrives. GraphRAG wins when the question is about connections, not content. Org charts, dependency maps, which X affects Y. Standard RAG still wins for simple factual retrieval, large diverse corpora, or anything that updates frequently. The graph rebuild cost is real. Indexing cost is about 10 to 50 times higher than standard RAG. Don't reach for GraphRAG until relationships are genuinely the bottleneck. Now let's talk fine tuning. Fine tuning and RAG are solving different problems. RAG manages what the model knows: fresh, auditable, scalable. Fine tuning changes how the model reasons: its style, its tone, its domain specific behavior. The clearest heuristic: if you need the model to behave differently, fine tune. If you need it to know something new, use RAG. So, how does fine tuning actually work? You take a pre trained model and continue training it on labeled examples, input output pairs that demonstrate the behavior you want. That's supervised fine tuning, SFT. The key question is which weights to update. Full fine tuning updates every parameter, billions of weights. Powerful but needs multiple A100s and serious budget. LoRa takes a smarter path. Freeze the base model, add tiny trainable adapters. Same quality, far less compute. QLoRa goes further. Quantize the base to 4-bit and apply LoRa on top. A 70 billion parameter model that normally needs 8 GPUs fits on one. For tools, TRL runs the training loop. Unsloth makes it 2 to 4 times faster. QLoRa plus Unsloth is where most teams start. Here's the decision matrix. If knowledge is static and behavior doesn't need specialization, a base model is often enough. If knowledge is static but you need specific reasoning style, fine tune. If knowledge updates constantly but behavior is standard, RAG. If you need both, fine tune for style, RAG for facts. A TechVault domain expert that speaks the company's technical language but cites live policies. That's the combination. Now to hybrid search that solves the vector search problem with exact terms. ERR 4291 handling procedure. The embedding model has never seen this error code. It has no semantic meaning in vector space. Vector search drifts to semantically adjacent documents. General error handling, timeout procedures. The right document is rank 7. BM25 would have matched it in milliseconds. It's just term frequency. BM25, best match 25, is the scoring function behind traditional search engines. Term frequency. How often does your query term appear in this document? Inverse document frequency. How rare is that term? Rare terms matter more. Length normalization. A short document with 3 mentions beats a long document with 20. No embeddings, no GPU, pure term statistics, and for exact terms, it's unbeatable. So, how do we use this in practice? Semantic queries, vector wins. Exact term queries, BM25 wins. Hybrid search covers both columns. For most real world document sets that contain a mix of semantic and keyword sensitive content, hybrid is the practical default. So, how does hybrid search actually work? A single query goes to two engines simultaneously: BM25 for exact term matching and the vector store for semantic similarity. Each returns its own ranked list. They don't need to agree. Reciprocal rank fusion (RRF) merges them. Each document scores 1 over 60 plus its rank in each list. A document that appears in both lists gets two contributions. That's why ERR 4291 rises to the top even when vector search buried it at rank 7. Sort by combined score and you have a single ranked output. Keyword precision from BM25, semantic recall from vector search working together. Let's run two queries side by side and see the difference in practice. First, a keyword sensitive one. An expense form code EXP 2024-Q3. Pure vector search has never encountered this string before. It has no semantic neighbors. So the model drifts toward general expense policies and finance contacts. The document you actually need comes back at rank 5. Now watch what hybrid does. BM25 spots the exact string in milliseconds. That's all it needs. RRF pulls that document to rank 1. The result that was buried is now on top. Now flip it, a semantic query. No form codes, no exact terms. Just a natural question about employee time off. Both pipelines return identical results. Hybrid doesn't degrade on semantic queries. When there are no rare keywords to match, BM25 scores stay low across every document. So vector rankings take over and drive the RRF output. That's the point. Hybrid gives you keyword precision when you need it without giving anything up when you don't. The complete decision framework. Start with the question: what kind of knowledge problem is this? If it's about relationships between entities, GraphRAG. If the knowledge is stable and you need consistent reasoning style, fine tune. If documents change frequently, that's the RAG family. Keyword sensitive domain, add BM25. Use hybrid search. Multi-step reasoning required, go agentic. Still seeing retrieval failures, add query rewriting and re-ranking. Retrieval quality still degrading, revisit chunking. If none of those apply, naive RAG was probably fine all along. Start simple. Add complexity only when you've identified the specific failure the complexity solves. 6 videos. We started with the problem: LLMs don't know your data. Built the storage layer, embedding ChromaDB semantic search. Fix the input, three chunking strategies, each solving a different failure mode. Improved retrieval, query rewriting, hide, re ranking. Gave the AI autonomy, a React agent that decides when and how to search. Then step back and ask the honest question: when is all of this the wrong answer? You now have both the tools and the judgment to build RAG systems that actually work in production. If this series helped you build a better mental model of RAG, subscribe and share it with someone else who's building these systems. The decision framework from today is the most practical thing I can leave you with. Start simple, add complexity only when you've found the specific failure it solves. Thanks for following along through all 6 videos. See you in the next series.